Entity framework, our tools.
Technology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shiro Dent.
Grace Lampson.
Martha Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Hi everyone, welcome back. We're here with another episode of .NET Data Community Standup. Just me and Shai this week, and we're going to talk about some EF basic stuff around value generation and how those are used for keys and all of that, how all of that stuff interacts. So should be fairly accessible, not too deep, but some interesting nuances that catch people out. So definitely, even if you think you know it, there's probably something here that you don't, but maybe not. Anyway, so before we do that, let's do State of the Unicorn. I found my State of the Unicorn slide, the official slide. It was on the cloud after all. So cloud for the win there. It's not lost. EFA 10 million NuGet downloads of 8.0.0.0.1 and 0.2. So if you're not on 8, get that now. There's, if you're just moving to 8, there's the aka.ms EF8-new. That'll take you to what's new for 8. Because I know we tend to like, here's 8, it's awesome, and then immediately it's just like 9. So like 8 is still there. There's a lot of good stuff. Go check it out if you haven't already. Preview 2 on EF9 is out next week. Obviously, as I'm always saying all the time, the daily builds are there. You can use them already. In fact, the what's new for 9 uses the daily builds. So, and I've just started updating that for some preview 2 stuff. But get it now and try what we have. And also, really important, Shai's been working on query pipeline architecture, so a lot of stuff changing under the covers in the query pipeline, and so we really need people to be running their code on that and testing out their queries as soon as possible so we can get good feedback on that. So try the daily builds, try stuff, see what works. I was gonna link to this, which I didn't, so let's see if I can do this without showing anything I shouldn't show. Here we go. Got it. Okay, so I've created a page on this is the EF Docs page, and there's now a link with a page for .NET Data Community Standups, and I will add this one to it. I was just saying to Shai before the show that I'm going to try and add it before the show next time. But basically, this is a listing of each of these, and for everyone, we have a brief description, link to the show on YouTube, and then the links. And this is kind of the important thing, because we didn't have a great way of getting all the links together so you could go find these things. So now for each of these, we have links to the products that we're talking about, blogs, doc posts, videos, all of that good stuff on there. So if you want to go back and find more stuff
Can you
from
show where that page is in our docs, by the way?
Oh yeah, let
In
me
the
do
table
that
of
right away.
contents, so people get that.
Yeah, so if you're at the top of our docs here, it's under Entity Framework Core, and then there's a Learn More section that has our API docs that moved into Learn More, and then the Community Stand-Up here, and then there may be some other things that I'm mulling over that go under here later.
Awesome.
But I created a short link to it, aka.ms-ef-standups as well, so that's
also awesome.
And I've now lost you guys on StreamYard. There you go, got you back. Too much stuff open on my machine. Okay, so that I think is that. But we have some slides, so let me come back to the slides in a second.
There's a suggestion here, Arthur, as long as we're talking about all the sharing links and so on, about whether we can also share code that we use in as example.
Right. So as part of that, what I try and do, and I haven't done it for everyone, is put the code that I'm using up on GitHub and then put a link to it in that doc, and that's what I'm going to do. So I'll put this sample up on GitHub, and we'll try and do that every time where we have code. We'll put a link to it on GitHub or wherever it is in the doc there. That's one of the most important links actually for each show that we want to share with people. Okay. So keys, value generation. These are really two different topics, but there's a lot of overlap. So what we're actually going to do is we're going to, let me remove this for now. What we're going to do is we're going to talk about value generation first, because value generation can be used for things that are not keys. And so we'll just look at it from a perspective of value generation. And then we're going to bring that over to keys and see how value generation is used for keys and how that then potentially influences other things that you do in your application. Okay, so I've got code. So let me add this back on again and show the code. So this is what I'm going to upload. I'll also upload, there's a Scratch file here which has all the snippets and stuff that I'm going to be using during the time. So even though I'll upload it as we go through it, if you want to find bits that aren't in the, go look in a Scratch file kind of thing, right? Okay, so anyway, I've got a DB context here. We're using SQL Server, and I've got a simple entity user. So this is going to create a users table. The users table has an ID. We're just doing this now. We're not talking about the key here, right? So this is here, and it's going to be value generated, but that's not what we're looking at right now. What we're actually going to look at is different ways of value generation for these non-key properties, okay? And so this is our sample code, and all we're going to do after we use this is insert a value and then insert an entity and see what value gets generated. Okay. When? So I've got two questions first. When and how do we do value generation? Okay, so this should be simpler, right? This has evolved over a lot of time, these things, and they're not very intuitive. So I'm going to go over them, but I apologize in advance that they're not intuitive. Shai?
Is it worth maybe stressing right now, if I understand you correctly, we're talking about value generation in EF, right? So this is not, or are we talking about them also in the database? Maybe we
also
should
in the database. Yes.
Make it clear. We're talking about all of those things. Okay.
We're not going to go into detail in the underlying database mechanisms for value generation, but we're going to show the cases where the database generates a value as opposed to the EF generating a value for you.
I think that's actually something that a lot of people aren't aware of. There are some cases where where EF is going to let the database generate stuff like
exactly.
IDs, or keys, but not only, as you stressed. So that I think is what people are more familiar with, right? Like you've got a sequence in your database and things get generated in the database. That's
Exactly.
one thing. But one thing that the other thing which maybe people are less familiar with is that in some scenarios, actually EF is going to generate your stuff in the client side, and
Yep.
then it's going to send that to the database. So we're
Exactly.
discussing those scenarios here.
We're discussing both scenarios, right? Okay, so back to this. So we have this value generated. So this is an enum, and also this in some of the Fluent APIs value generated never, for example, or onadd. The only one of these that's really intuitive is never, which means EF is never going to generate a value. So done. So onadd is also, I guess, relatively intuitive. We're going to generate a value when inserting new entities. OnUpdate is interesting in the sense that it's when you call save changes and update an existing entity. So this onadd is for an insert into if we're using a relational database, and this is for an update. However, EF value generators, we'll get to that next stage, don't generate values for update. So this happens on update, but it's complicated because of what actually happens on update. On update, sometimes that's Andrew. Like, I still don't fully understand why we need on update sometimes. I'll get Andrew to come on the show at some point and tell us why we need on. He might be watching and he can put it in the comment. But yeah, that one is, honestly, as a user, I don't think you're ever going to need it. It's very complicated cases where you've got overlapping keys and you want to set this sometimes, but in other cases where it's used in a different way, it doesn't get set and all that stuff. Onadd or update is just onadd or update. So when you do both. So actually, this seems like it's intuitive until you get to the next bit. And the next bit is what happens in each of these cases. And this is where I alluded to it's complicated. So onadd can use a database default. So we'll look at that, a default constraint on the column. You can use that, and onadd will use that value with a caveat. Or it can be a computed column. Again, the database generating it. Or you can use an EF value generator. And so this is somewhat goes to what Shai was saying about EF generating values, although you use value generators even when the database is going to generate values as well. So we'll come to that in a minute, because the value generator then generates temporary values. But the main point of this slide is the value generator is used on add. It's not used on update. So if you do value generated on update, your value generator won't be called to generate a value for that. More interestingly, on add or update, where you would expect the value generator to be used when it's added or when it's update, no, the value generator gets used on add because it's on add, but it doesn't get used on update because it's on update. And so that's not great, right? And as a consequence of that, we have an issue here. My friend John P. Smith, it's got 45 votes, which is, somewhat up there. But you might want to vote for that if you decide that, whoops.
Ooh, infinite
All right.
recursion.
Yeah. You might want to vote for that if you decide after hearing all this that you actually want value generators to run on update too, which I think would be a good thing to do ultimately. Did that make some kind of sense? The main point here is that value generators only run on add. So
the thing to keep in mind is that distinction we talked about. There's server generated and there's client generated, right? And the thing I think historically that happened here is onUpdate was mainly introduced to handle the server generated case, like a computed column, basically, right?
Yeah. It just came directly from the old stack and didn't really change in any way. Whereas value generators, we added to EF Core and they got integrated into the add part of it.
So we're kind of missing the client side for onUpdate. Basically, this is what it is. But onUpdate does work very well for the case where we're on the server, and I think you're probably going to be demoing that.
Exactly. That's exactly what I'm going to do
And,
right now.
we're always interested in cases where where you want that kind of thing. Like I'm personally interested in what case would you necessarily need to generate. So basically, what this means is you're updating something via EF Core. You're doing save changes. You've updated something that already exists, and you want EF Core to automatically calculate something for one of those properties every single time. So on every single change. It does bear, so keep in mind, right? When you have a computed column in the database, that means the database computes the update. If anybody else, for example, is not using EF, like you have something in Python or some other C# program, then they don't know about your value generators and inside EF, right? Anything on the client is only when you're using EF, whereas what you're doing in the database is obviously going to always work regardless of the client you're using. So it's always interesting to me, at least, to hear like what scenarios out there people actually need this for. But
Yes.
yeah, let's go on.
Okay, so what we're going to look at is the three database, the three methods for to have EF say the database is going to generate a value for this case. So none of these are now involving value generators at all. This is purely about telling the database that you're going to generate it. Okay, so the first one is has default value. So what has default value says is take a value that is of the type that my thing is, create a SQL value, like a SQL expression of that value. So in this case, obviously it's an enum. So if that's mapped to a string, it'll be a string expression. If it's mapped to an integer, it'll be just a number. But take that and make that the default value on the column. And at the same time, make EF use it. So that's what this value generated add says, make EF use it. You actually don't need this. In any of these cases, you don't need this. If you tell us we have a default value, we'll automatically say value generated on add, right? I'll come back to that in a minute, but I'm putting it in for clarity. So in this case, what we're saying is we have set this as the default value in the column. Okay, so if we run that, and I think all I've got it doing at the moment is creating the database, but we should see that. Okay, so in the database, you can see here that status now has a default of 1, which is the value of new in our enum there. Okay, so likewise, has default value SQL is the same as has default value, except that you tell us the SQL expression directly. Right, and so this is typically used because you want it to be a function. So in this case, like get UTC date is what I want. And this is a very common way to do a timestamp. This is when it's inserted, just have a value that is the UTC timestamp at that point. You could, for this first one, you could do this, right? 0 or whatever other formatting you want around it. Don't do that. Do that. Why? Because EF knows what this means. This is opaque to EF. It doesn't know what this means. EF knows what this means. And that's important when we're talking about sentinel values and deciding what to do about things, which we'll get to later. So, but generally, I'll come to you in a minute, Shai. Generally, if you can give EF more information about the semantics of what you're doing, then that's better. And this one does that, whereas this one just says, I don't know what it is. You just, EF, you don't know what it is, just trust me, this is what you want. Jai?
I want to hammer on that point a little bit. So EF almost never, ever looks in your SQL, no matter what you do. This is like a very, very fundamental design decision that we made. I think it's absolutely the right one. I mean, there's no doubt in my mind specifically that that it's the right decision. We can't start looking into, for example, that default SQL that you see here. We can't start looking into it and trying to make sense of it. That's an arbitrarily complex SQL thing. As if that wasn't easy, as if that wasn't hard enough. This SQL thing actually varies from database to database. So this might be the SQL Server way to ask for a UTC date for now, but in Postgres it looks completely different. And there's no way we can start actually understanding all the different SQL dialects of all the different databases in the world and so on. So it's very important that whenever you're writing SQL, you should understand that EF really takes it as a string and embeds it somewhere in your query, in your migrations. Doesn't really matter, but it's just going to stick it in somewhere, and it's not going to look into it. It's not going to know anything about it. So don't expect any sort of smarts from EF when you do something like this. And that's basically what Arthur was just saying. When you use the above thing, with has default value, there's no SQL. You're communicating with EF like a .NET API, like it's meant to be, right? That's the nice way, right? You're giving it the default value. The moment you drop down to SQL, this is basically a form of raw SQL, a bit like when you use raw SQL in your queries or whatever. All bets are off at this point. Like you need to know what you're doing. EF will not do any correction for you or anything like that.
Right. So so you can see again in the SQL, in that case we generated the default for the column with get UTC date. Okay, and then the last one here is has computed column SQL. And has computed column SQL is very similar to has default value SQL, except it makes the column computed instead of just having a default constraint. And there's various other things you can do to the computed column in terms of persistence and all of that kind of stuff. But fundamentally, this means that the database is going to generate a value every time you query this thing. It's going to run this calculation, right? And so this is a way in this case of having a computed column in the database. And that could be a variety of things. In this case, all I'm doing is concatenating first and last name basically together to make a display name. And you can see in here that we have this is the syntax for creating a computed column display name as, and then the SQL that should run for that column. So again, that's in the database. Now, has computed columns, so computed columns, this is what Shai was getting at earlier, align with value generated on add or update and always have done. And so in the same way as these ones aligned with on add, you can actually remove this from here. And then EF will automatically say, oh, okay, you want that to be a computed column. Okay.
Is it worth saying a couple words on what computed columns are to make sure people
I
know?
thought I did, but if I miss something, go ahead.
Okay. I mean, there's also the thing of persistent versus virtual.
Yeah, I mean, if you want to talk about it a little bit, that'd be great. Yeah.
Maybe I'll say a few words, right? So, the default value that you saw on add, the stuff on add is not really that interesting. An on add kind of column is just a regular column. I mean, you can write and read into it. It's just what it gets by default if you don't specify when you insert a new thing. However, computed columns are very different. They're sometimes called, like in Postgres, they're called generated columns. The naming is different. But the general idea is that these are columns that you don't manage yourself. When you create them, you define at that point what they contain. You give an expression like you just saw in SQL, and you can't actually set them to anything ever. They're always just automatically computed for you by the database, right? So that's already weird, right? It's like a read-only kind of column in that sense. You can never set it yourself. Typically, what it's going to do is how Arthur kind of demoed it. It's going to be I'll finish just a sentence. It's just going to be like a computation based on the other columns. That's like a very, very common kind of case. Like one very common example, if you're doing a full text search kind of thing, maybe one column is going to be, a calculation for it's going to be the vector or whatever you want to call it. You're going to have some sort of thing that's derived from the other columns, right? Maybe if we're in the world of AI and we're doing vector database search, maybe it's going to be some calculation of the embeddings or the vectors of all your text in your column, right? And then at that point, that thing has been derived and it's there, but you cannot change it directly yourself. I still have to talk about some stuff, but Arthur, you raise your hand.
No, you finish and then I'll come back in.
Okay, one last thing about that. So it's a very useful feature in database, or maybe two last things. So there's two types of computed columns, like in SQL, in most databases. One is, let's call it a stored one, and the other one is a virtual one. So a stored one basically takes space in the disk, just like a normal column, right? So there's space allocated in the disk, and whenever you change a row, then the database is going to recompute that, according to the expression that you gave when creating the table. It's going to recompute the value and it's going to store it to disk. And then when you query, you just get it out of disk, like in the normal way. It's just a normal column in that sense. Virtual computed columns are very different. They don't take up disk space at all, so they actually don't exist on disk at all, like a normal column. Instead, whenever you query them, you get back the calculation at that point. So they're kind of calculated just in time. Let's call it like this, right? It's a very, very interesting kind of thing. The question is whether you're calculating them when updating the row or when you're selecting the row. That's basically the distinction. From a user's perspective, when you're a database programmer, there's actually no difference. There shouldn't be any sort of difference between them, right? What do you care when it got computed, as long as it always reflects the right answer, right? And it does. The difference is obviously in, is it going to take space on disk
That's
versus,
different though, right?
sorry?
That's different. What I just wrote there might not be valid SQL, but
It
that
is not.
matters
It
whether.
is not valid. Yeah, it is not valid SQL. In
But my
fact.
point is, you said it doesn't matter. It can do, and I was,
Yeah,
yeah.
yeah.
But keep going.
You're right. Yeah, you're right. I mean, yeah, I'll get to that in 1 second. So basically, it's a trade-off. Do you want to pay with more disk space? And at that point, the values are only calculated once when you change the row, or do you want to pay with calculation time so that every time you query, you're going to be paying for that, paying that cost, right? So if it's going to be an expensive calculation, like a vector database embedding kind of thing, where there's like a big transformation happening to create that value, you absolutely want it to be persisted, right? You don't want to calculate that stuff every time you compute it. On the other hand, if it's like just a concatenation between two other columns, like we've seen in this example, it doesn't matter. It's basically like a shortcut. You could have just written it yourself in the SQL. There's no like a computation cost kind of thing here, so it doesn't really matter that much. And how, like what Arthur was now alluding to, there are certain restrictions on what you can put in computed columns. Specifically, if it's going to be stored on disk, then it cannot contain, let's call them non-deterministic functions. Like if you take the current date, you can't store that on disk because it's calculated on update, and then it's going to be wrong later, right? If you select it like an hour later, the expectation is for that to always be up to date. But that means it has to be recalculated when you query it rather than when you update it. So certain things are not possible with stored computed columns and are possible with virtual ones. I hope you get the idea. There's maybe one last thing. I know I'm kind of rambling, but it seems relevant, or at least to me, it's kind of interesting. You can, in most databases, when a column is persisted on disk, it's kind of like a regular column, you can define an index on it. That's actually pretty powerful. So you can create an index on SQL Server over a computed column as long as it's persisted. That's actually a pretty cool way to create an index over any sort of expression. So let's say you have some complex expression. You want to do select something for blocks where blah, 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 blah. And the blah, blah, blah is, this big mathematical or whatever. It doesn't really matter. You can take that big complicated blah, blah, blah thing, and you can put it as a computed column there. And if it's stored, if you made it stored, then you can also create an index on it. And at that point, if you do your select, it's going to run super fast. You don't have to actually calculate it every single time, right? But of course, it has to be stored. It can't be calculated on demand. So yeah, I think my ramble, like my rant or whatever you want to call it, is.
So I'm gonna follow up on that, right? And also with a question we have here, which is, can I write computed columns with C# expressions?
Yeah, I just answered that in the chat, like one message above. Exactly.
It would be good. But so I'm not doing that. And I want to be very clear that I'm not doing that right now. I'm doing something which I'm going to ask Shai why I would not do this. Because you were asking about scenarios, right? Why would I not just do first name plus...
I don't know. Why would you not do it?
That's the wrong syntax. But if I can actually write C#, because I don't actually want to do that. I just want it to be computed.
Exactly.
So why not just do this? This will work. I mean, I'll probably, if I run it, it'll probably crash because I haven't, anything that you haven't actually tried before you do a live demo will crash. I'm serious, Shai. Do you know when a reason you'd use one or the other?
So, I mean, I'm sure there's going to be some discrepancies, right? Like if, for example,
I just curious.
I never thought about it, to be completely honest.
This can't be used in a query, right?
Oh yeah, of course.
You do know this. You just hadn't thought about it, right?
That's true. Yeah.
And it's actually a bit related to the question about could we do it with C# expressions, in the sense that it would be really nice if you could have a computed property that was defined like this and somehow you could use in a query. But right now you can't do that, right? The database has no knowledge about this. EF is not able to construct it in any way or anything like that. And so this is fine and this is great. like if I were just wanting to have something that is displayed in my UI as a display name, I would do it like this. If I actually want to write queries that are going to use the display name in some way, maybe they generate a document or something and it's important they have the display name in it, then you're going to have to do something on the database. And so that's a scenario, that's one reason why you could have a computed column for SQL in that way.
You might as well just make this not mapped, right? If you do this for display purposes, then there's no reason for EF to even know about it, right? I'm just kind of continuing.
You mean like this one?
Yeah, exactly. Like if you did,
it doesn't map by default.
Oh, it doesn't even map.
It doesn't have a setter
because it doesn't have a setter, of course.
Yeah. So it does the right thing by
default.
I'm
learning EF. That's super cool. Super cool.
Yeah.
For anybody in the crowd, this is not a show. I actually am learning that stuff now because Arthur is the big boss of anything related to this kind of stuff.
I don't know about that. Anyway, okay. So what was the other thing? Yeah. What this doesn't do, and I think what this doesn't do is perhaps even more important than what it does do, because the two scenarios that are probably, I would say, the most common for non-key value generation are a created timestamp and a last updated timestamp, right? And the created one's super simple. We did it here. That will put a UTC timestamp when it's created. You can't use a computed column to create a last updated timestamp, because if you remember how Shai described to you how computed columns work, the value, if it's persisted, you could put a timestamp in the persisted and that would be like when it was created, but it won't let you do that, right? It's like, no, you can't do that. And obviously if it's non-persisted, it's just the time when it was queried. So all you're going to get if you do if you write get UTC date in here, which I believe is now valid, we'll run it and see.
You can give it a try. Yeah,
if I can copy and paste.
So do we get persisted or virtual by default? I don't even remember. I think it's virtual by
default on SQL Server. Yeah. Right. So you can do that. And if it's actually a segue into, let's actually run this code and see what we get out of the database here. This is totally not what I planned, by the way. But okay.
Awesome. That's awesome.
Yeah. So save changes. Okay, so what I'm going to do here is we're going to create a new user and save it. So we'll see what's inserted, and then we're also going to query it back, and then I'm going to mark everything as modified. This marks everything as modified, remember, and save it. So we're going to see, assuming it thinks everything's modified, what does it write? So we'll come back to that question on the UTC time and see if that works in a minute. But let's just go through and look at the other ones. So I'm going to run this code, and remember what we have here are it doesn't matter if it's the wrong computed column. So we've got a default value, it has default value SQL, and it has computed column, and we got an exception.
Of course we did. Somewhere down below, right?
Yeah, it's has no configured sent. Oh, yeah, right. That's because why is that? Oh, yes.
Is that the error though? That's just a warning, because there was an exception down below somewhere, no?
Yeah, I'm gonna put it back to what it was before, and then I have a better chance of getting this right. Okay. So let's sorry about this. This is what happens when you change the demo on the fly.
That's what we like though.
Okay, so we're adding new user. Okay, hopefully this will work, and we'll look what's get inserted. Okay, good. Okay, so here you can see we are inserting values for first name and last name, as we'd expect, because we've specified those. We're also inserting a value for the updated column, which is this the updated column, which is this one, right? So notice that even though, hang on, did I set that as computed? No, I didn't set updated as computed. I guess I was going to show that. So we're inserting the updated column, but importantly, we're not inserting a value for the computed column, right? We never insert a value for the computed column. And even so, taking a step back here. Okay. The thing I wanted to talk about here really is when we send a value to the database and when we don't send a value to the database. That's the next bit of this puzzle. Okay, so as we've seen here, because I told it, okay, has a default value here and has a default value here, we didn't send any value to the database. So we just didn't insert anything into those columns, right? That's how you tell SQL Server use the default on that column, by not including it. But EF has the capability to include a value if you explicitly set it. So if I was to say here for the status, if I was to say, actually, I'm going to set that to deactivated when I insert the record, then what's going to happen is that EF will actually include that value because you've set an explicit value. So now you can
How
see
does it know?
status included.
But how
Well,
does it know?
yes, exactly. How does it know? Well, it knows because this is now not the CLR default. And in reality, it's not the sentinel value because you can actually change it, but we'll come back to that later. For now, let's just assume that if the value of a property is not set to the CLR default, then EF is going to assume that's because it's been explicitly set, and therefore you actually want that value to be inserted into the database. So this will come back to this again later when we look at keys, because this is important for when you are trying to explicitly insert a key value and how different databases can handle that. That, by the way, that scenario in being able to explicitly insert key values is primarily why we did this, because when you want to seed data, for example, inserting key values explicitly is, when you're testing, it's very useful. And so on the old stack, on EF6, legacy EF6, you couldn't do any of that. If it was value generated, it was always value generated regardless. We just ignored the value on the entity entirely and just generated a value always.
Maybe it's worth mentioning databases also vary in what they support here. But for example, Postgres, you can have a column that's always value generated and will, like an identity column, that you cannot override. Like it's always only database generated. But the more common thing is what's called identity by default, which means only if a value has not been provided. But if you provide a value, that's going to override that thing. And SQL Server by default doesn't allow you to override an identity column. But there's this switch thing. There's this thing that you can set if you want that says, from now on, actually do allow me to to insert my values. And
that's what I was gonna get to when I said we'll come back to this with keys later on.
I'm sorry.
Okay.
I'm screwing up the whole thing.
No, it's fine. Okay, now I have to remember where I was at. Okay, so yes, that one didn't get inserted, and it would be the same also for the date one. If I actually specified a date on here, then that date would get inserted explicitly. So if I did this, I would now get a UTC timestamp from the client at the time that code run, and that would be inserted, I hope, if this works.
It should.
Yes. Okay, now, what happens if I try and set a value for a computed property? So what if I do display name equals 7? I don't know why I just came up with 7. Let's display name equals toast. That's better. It's really weird. Willow and Toast are my dogs, by the way. Okay, so if I run this now, I think this will actually succeed, but I'm not 100% sure. Yes, it did. But it succeeded because even though we set an explicit value, we didn't actually include it in a computed column. And that's because the default behavior, you can change this, But the default for behavior for computed columns, that if you set a specific value, we don't include it, because as Shai was saying earlier, you can't update it anyway. Now you can write triggers, and this is why I was actually going to come in. There's trigger. You can do things that will allow you to create a column that appears to be computed, except if you include a value when you can do all that, right? You can write triggers to do all that. And so EF allows you to configure the behavior here. So you could actually say, tell EF, and this is the before save and after save behavior that, again, we'll show later if we get time. You could say it, but by default, EF is not going to use that value just because you specified it. Shai.
I do want to just point out, if we look at the actual SQL, right, there's the insert, which we've been focusing on, and then just below there's the output, right? Which is, and should I say a word about that?
Yeah, go for it.
Yeah. So output is a way for us to say, insert a new row into users, but send us back these two values here, right? And notice this is actually a very important thing. So the word inserted is some SQL Server thing for saying the row that was just inserted, please give us back the ID and then the display name for that thing. And notice that these are the two properties. One is generated on add and the other is generated on update, right? And what you're seeing here is that EF is requesting, it's inserting and giving the first name and the last name and the status, and all that is going into the database. And at the same time, it's requesting to get back the ID and the display name, which it knows our database generated because we've just configured it that way, right? So see how interesting and kind of cool this is. The first name and last name, which make up the the display name, we input into the database, and then we request back the display name out. Right? So EF is not calculating that itself. That's again a very important thing. It's database generated. As I said, EF doesn't look inside the SQL. It doesn't know, oh, I think there's another being here joining our
that's people don't get to see Mac very often, so that's
I've not seen him in this particular position yet, and I see you quite a lot, Arthur, in this place. That's very funny. I like it. So yeah, basically what I'm trying to say is, as far as EF is concerned, display name is opaque. So it's sending in the inputs and it's getting back the display name. It doesn't know that, on the SQL Server side, those two values are just going to be concatenated and it's going to get back. But that's the way it should work, right? So it's kind of nice to see that anything that you've configured to be on add or on update or one of these things, they're going to get requested back from the database instead of appearing in the input of the thing, right? And I'll just go back to one thing that Arthur said. Yeah, triggers are actually important. So we only discussed computed columns as updatable, as generated on update, but there's other possibilities. So you can do arbitrary things, as Arthur hinted at, with triggers. You can say that whenever some row is updated, then some column in that row is going to go and fetch something from any arbitrary thing, right?
Yeah.
Which is another example of generated on update. And I think it's I'm finishing. I know I'm talking a lot in this stand-up. It's worth making the distinction. On update is basically EF's concept of what's going on with that column, right? It only means, as far as EF is concerned, that it doesn't send the value there and it needs to request it back whenever a change happens. But it says nothing about the specific mechanism on the database side, or even maybe not on the database side,
exactly,
as we'll probably see. Those are completely different things. There's like whether it is generated and when, add, update, and whatever. And then there's the mechanism, which is very frequently going to be very database specific for how that thing gets actually updated. So that was my speech.
Yes. So I just also, it reminded me that we didn't actually talk about what you actually, this is a docs page here. And if you do want that update timestamp, we have a sample trigger. People are always sending us things saying this trigger's not good enough. It doesn't handle this case and that case and the other case. That's because triggers are difficult, and we wanted to have something that was at least easily understandable. But this is basically showing you that you can do this and you can create an update timestamp by using a trigger and then configuring EF appropriately. Okay, I just, since Shai was talking about generated values, I just updated the demo. So we're going to update the display name before we insert it and then after we insert it. And because I actually initialized it, I forgot I initialized it. I was thinking it wouldn't be set, but you can see that before we inserted it, it's toast. But then after save changes is called, as Shai said, the the expression was run in the database and that output value was returned, and so now it's Vickers, Willow, and that's
and I think that's a nice thing EF gives you for free as well. Like, people don't think about it, but EF guarantees whenever it does a change or it inserts some new row into the database, after you've called save changes, you're going to have like the up-to-date database generated values there. That's actually not trivial at all, right? So you can, after save changes, you can read them and send them somewhere else, and it's going to be the correct ones.
And of course, it's most useful for keys where the key is now in the entity after it's been saved, which you didn't know what value that was going to be before.
Indeed.
Remove those. Okay, so let's look next, if I can find my notes again. Let's look what we do when we actually run an update instead of an insert. So I'm going to, like I showed this code before, I'm going to get the single user that we inserted. I'm going to mark all properties as modified, and then I'm going to call save changes. So what we should see is that, again, the computed column, the display name, is not included in the update, but it is requested from the database. So every time we run an update, we will get back the appropriate display name, just like when we run the insert, we got back the appropriate display name. And by default, we'll never include it. Even if we mark the property as modified, it doesn't get included by default, because by default, computed columns are not updatable. But after save behavior, you can change that. And if you've got a trigger or something, you can have it send the value if you want and make it do that. Okay, so let's see. I showed that. Yeah, she did that. Okay, so I think we're going to put a stake in the ground there, even though we've done 43 minutes already. And we're going to say, okay, let's talk a little bit about value generators and how value generators work. I believe I have a slide for this. Yes.
Ooh, a slide.
Okay, so a value generator can be set on any property. That might seem like a silly thing to say, but people usually use them. They're usually used for keys, but you can set a value generator on any property. Okay, they can generate any kind of value, so they don't have to generate key values. Again, should be obvious, but I'm just kind of making sure that it's explicitly said. The different kinds of values that they can generate, they can be permanent. So, we'll see examples of this in a minute, but this goes to what Shai was talking about a little bit versus client side versus server side. So if you want a value that's just generated by the value generator and that value is inserted into the database, then you generate a permanent value from your value generator, such as a client side GUID, and that gets inserted. You can also generate what are called stable permanent values. That is, a value generator that generates GUIDs will generate a different GUID each time you call it, right? A stable value generator, which we use, for example, for discriminator columns, will, given the type of this entity, generate me this value, and it's the same every time. And so it's unusual for application developers to implement stable value generators, but you can, and they can be useful. And then, of course, the final one, and this is the one that's actually used most common, is temporary values. And this is where you want you want the database to generate the value, but you don't want to send anything to the database right now. You don't want to communicate to the database to get that value, because that would be incredibly inefficient to have a round trip to do that. So EF generates a temporary value, which is generally a big negative number. And then when that value gets inserted into the database, the real value is returned. And we'll see that a demo of that as well.
Is it worth discussing why a temporary value is needed in the first place? Like, I think it took me a long time to understand this. Like, I remember, like, when I got
okay, why is a temporary value needed in the first place, Shai?
Right. So, like, when I was a naive person, so the question we're asking now is this: let's say you have you're adding a blog, right? And the blog has a database generated ID, like an identity column, like the completely normal thing. So you've added it to the change tracker, but you've not done save changes yet, right? So the question is, what is the value of the ID, right? So in the blog, nobody's touched it, so it's 0, right? So one could say that the value is just 0 at this point. Why do we need to do anything else, right? And you'll probably maybe correct me as well. But the interesting thing is that inside EF's change tracker, there's this notion of relationships between things, right? So you have posts that might be pointing to that blog that we've just added, and there may be several blogs being tracked right now at this moment, right? And there may be several posts for each one of those blogs. So we still as EF will still need to represent those relationships inside the change tracker, and this is why each one of those blogs needs to have its own unique ID, right? Am I
Yes,
that's the correct
exactly
thing?
it. Yeah.
We haven't discussed this before, so I'm happy I got the correct
And I'm
understanding.
going to probably blow your mind again. Legacy EF6 doesn't do any of this. It doesn't have temporary keys. It doesn't have a way to identify an added object by its key. You cannot look up an added object. Actually, you can, because
That's
there's
interesting.
a method on DB context that iterates through them and does it, but it's incredibly inefficient because it's not stored. Essentially, it has a completely separate state manager path that stores that when you have an added entity, its object reference becomes its key.
Right.
And it's really weird. And
So,
temporary values work
we're
way
now
better.
So we're really inside EF internals now. This is not this is a part that's for
I said this was going to be an accessible stand-up, but anyway.
Hey, we can do what we want, right? So is it right to say, like, as a summary, that users shouldn't worry about temporary values, and basically they should I don't think they should ever actually have configure a generator that does temporary values? Is that correct?
Well, yes, you should configure generators that have temporary values. That's the most common generator that people use, like our integer value generator, right?
Right, but that happens by default. That's not users doing
by convention, or if
right.
I think it's reasonable for people to use temporary value generators for keys. That's very common. What's less common, as you're saying, is for any keys, it's less common to actually explicitly set a value generator. And we'll get into how keys work. In fact, it might be the next one of the next points on here.
Shut up now.
So they only run on inserts. We talked about that at the beginning, but bring it back. They don't ever run on updates. And they only run when the value is the sentinel value. So this is very similar to the point we made about when we insert a database value, insert a value in the database, like send a value to the database. If you set it to something that is not the CLR default, not the sentinel value, then a value generator typically will not generate a value for that. That ties in with this whole mechanism that if I've set a value explicitly, I want to send that to the database, and that works at the value generator level as well. Okay, so I think we're just going to go look at code here, which is good. So I've got a value generator that I've written here. It's super simple. Just insert some usings there. So this is value generator that says, okay, for this status enum here, when you generate, when you are inserting a new entity, I want you to generate a next value and always be new. So this is actually a stable value generator. We should actually override stable in here. It doesn't matter in this case for the demo I'm doing. Okay, and now put keys aside for the moment. Remember I said value generators can be set on any property. So I've written a value generator that's not generating values for keys. This is not a useful key value, right? It's the same thing every time. But I can still go into my configuration here and say, okay, this now has a value generator, and I'm gonna remove that config. In fact, I'm going to remove all of this stuff because we don't really need this anymore. And I'm going to remove it from here too. And from the user type, let me give me some more space for the user type. Get rid of all that stuff just to simplify this down. Okay. Oh, I got rid of status. Need that one. Other than status, get rid of that one and those two. Okay. So now in my configuration, I've said the status property has a value generator, and I'm telling it this is the value generator type. Typically, you just give it the type. You can do instances of for compile models and various other reasons. Giving it the type is better. This also is value generated on add, right? When you do this, we say, okay, you want to actually use this value generator, so we do it automatically for you. And then when you run this, what we should see is that, no, it didn't. What did I do wrong? Oh, yeah, I think I need to not call value generate and add here. That might be a bug.
Interesting.
Yeah. Yes. Okay.
Oh,
so,
yeah.
So what we've done is we've inserted a value for status, right? We haven't let the database generate, even though we didn't explicitly specify anything in the insert here. So the insert, I didn't say what status is, but the value generator decided, okay, I'm going to run because
Wait,
it's
that's
the
the
default.
update, right? You want to
Oh,
look.
is that the update? Yeah.
Yeah, you want to look further up. I think exactly.
Here we go. There's
Yep.
the insert. It's still there. Yeah, and so the value generator inserted. Okay, so that's what value generators do fundamentally, right? It's actually really simple. If you haven't set a value generator runs and it sets a value. So how are they functionally primarily used? No pun intended, for keys. That generally wasn't. I didn't intend that pun, but so let's look at keys, and then we'll just one slide here, and then we'll go look at how this actually works with code. Okay, so the critical thing is that a key property is configured by convention as value generated on add. In other words, we're going to generate a value for you if the type is an integer type or a GUID type. I don't think it's any numeric type. You can use a decimal key. Please don't.
I think long is like integer in the large sense, right? Like not
What
just
integers? Yeah, is an integer type as in long? I don't
short
remember if
even.
short does. I can't remember if we did byte by default. There was a huge discussion back in the day as whether we should generate for byte by default. Don't have byte
That
keys.
makes no sense. But yeah, anyway.
Anyway, so yeah, so if it's some integer type or a GUID type, then you get value generated and add by convention. But as Shai has said several times, that does not say anything about how the value is generated. Okay, and that is dependent on both EF and the provider having interaction to decide that. Also, we only do this if the key is not composite. So a simple key is where the key is made up of a single property. If you've defined a composite key, even if one part of that is an integer, it won't get value generated by default. And you could argue that, but the reason is typically if you've got a composite key, it's because the totality of that composite key is unique. So having a value generator that generates a fully unique value for one of them, like why have you got a composite key then? So, but you can explicitly configure one part of it to generate, and people do that. And that's why I'm just said that you can explicitly configure to change the value generation option. So I could say and we'll show that in a minute, but I could say my integer key, I don't actually want you to generate values for, right? I'm going to always explicitly specify the value. Okay, the next part of this is this whole thing here where we created a value generator and set it. As you're probably aware, you've probably not done this, right? Because you don't actually have to explicitly do this for keys. This is the part of the key meshing. We have this thing internally called the value generator selector. And what this does, it says, given the provider and given this property in the model in this context, tell me, provider, what value generator I should use for that, and it will return one. And that's how the EF and the provider together decide how the value is going to be generated. That only happens for properties that are part of a key, and this is one of those nuances that I mentioned, right? You can put value generated on add. I think Shai did. I just remembered Shai doesn't like this. You can put value generated on add on a property. It will not get a value generator unless it's a key, right?
Yeah, I never understood.
Why is this? Because these are key value generators. They're designed to generate values for keys. So that status value generator, for example, that's not a key value generator, right? That's it. It would be if I put value generator and add on the status property and it generated me a value generator that generated a different value from the enum each time. silly. It's because it's not a key, so we don't know the semantics of the property, and so we don't generate. Now we could, of course, just say you probably want incrementing integers, but we don't do it by default. But you can configure a value generator to do that, like we said. Right, so that it only happens part of a key.
So the takeaway, I guess, if anybody's interested, for example, you can choose some GUID property inside your entity. It's not a key, just any GUID property. If you want that to be automatically generated as random GUIDs, that's perfectly fine, and you can do that. You can go in EF Core in the on model creating. You go to that property, you say set value generator, and you tell us to use the GUID value generator that EF has built in, and that's going to work just fine. Like something like this exactly. There's a lot of that's a built-in one, and that's going to give you random GUIDs as if you basically called GUID new GUID every single time, and it's going to put them in. So EF kind of comes with all that in the box if that's what you want to do. Arthur's point was that we do this automatically for those properties if they happen to be a key property and also not part of a composite, right? So it does happen automatically for you in that very specific context, but even if it doesn't, you can still configure it explicitly yourself. That's basically the message here. Arthur, is it worth comparing the int to GUID key kind of situation, or are you planning on doing this later? Or
I'm doing it next.
Let's go.
Okay.
Because I find that fascinating.
Actually, I am gonna do that next, but with a slight interlude, which is just I'm just gonna do a quick refresher course on EF keys. Maybe I don't need to do this, configuring keys. I think I was going to point out that even if you make this, for example, key, so it's not picked up by convention as a key, and then you say has key. So I could just do, for example, in here, I can see B has key, right? So I've now said that's the key. This will now get the value generated convention, even if the key itself the name is not picked up by convention. That's something that sometimes gets confusing. They're two separate conventions. Once we found a integer property or a GUID property, it's going to get the value generated convention, even if it wasn't found, that property wasn't found by convention. Okay, so I think that's all we need to show on that. And I'm going to go to let's inserts. Let's do some stuff. We're actually going to start with GUID because GUID is the simplest. So I'm going to go to my class here, and I'm just going to make this a GUID. And then let's do, I've got some code here to write out what happens when we're doing the insert. Is it the insert? Yes, so here. Okay. So what I'm going to do here is we're going to write the key value out as we see it on the, let me comment this one out for a moment. So we're going to write the key value out before we've done anything to it. Then we're going to write the key, then we're going to add it. So now EF is tracking it in the added state. And then we're going to write the key value out again. And then we're going to call save changes. And remember, save changes will return the key value if it was generated, and we're going to write it out again. So what we're going to see here is the key as it's set on the entity, the key before it goes to the database, and the key after it's come back from the database. Okay, so if I run this, and remember we've got a GUID key with no explicit configuration on it, and by default EF is going to do client-side generation for that. I'll get into what client-side generation it does in a second, but it's going to do client-side generation for that. Oh, did I not actually do an insert?
I think there's only
save changes. What? Okay, let me comment out this. Don't need that right now. That's right. I just made another call save changes at the end there, I think. Okay, let's try that. Okay, yes, that looks like what we were expecting. Okay, so the key before add, it's the default GUID. GUID is a value type, so you don't get nulls or anything, you just get the default GUID. So EF detects that that is the case, it generates a GUID, So the instance we get after it's generated is this, and you can see that when we insert it to the database, it doesn't change. And in fact, we don't even record it back from the database because we know we're just explicitly setting the client value. So this is purely client-side generation. Go ahead, Shai.
And you can even see the same GUID in the parameter list. If you look at the command, the input command, you can add. So EF basically generated that value when you did add in EF itself, and then this got sent to the database via a parameter. So purely, like Arthur just said, purely client-side generation.
Yes. Now, it's actually generating different GUID than if I use the in-memory database here. And the reason for that is that we have a specialized GUID generator for SQL Server that attempts to generate sequential GUIDs that work better for clustered indexes. How well it does at that, I don't know. We've analyzed it, and it's useful in some cases, but not useful in other cases. So that's an example, though, where even though it's client-side generation, the provider has actually had an input to say, I actually want to use a special GUID generator here as opposed to just using a default one. Whereas if we'd used in-memory or SQLite, for example, we would have just got the default GUID generator that we used explicitly before. But either way, it's all just either way the GUIDs have been generated on the client. So what then if we wanted to actually have the database generate those GUIDs instead, right? Like because then the database can really understand its indexing system and what values are there to generate potentially more appropriate GUIDs that are more performant. And we've discussed whether this should actually be the default for SQL Server. But I can do it by going back to my configuration here and saying, okay, well, this actually it's not the status one, is it? It's the if we go to the ID property here, I can say that has default value. So I can't. What am I doing? Oh yeah, has default value SQL, and then the SQL for. Sorry, my brain froze. Like, what am I saying it to? Do you remember what the syntax is for?
I think it's called new sequential ID, but let me confirm with Azure.
Something like that. We'll find out when I run it. Okay, so now we've told EF actually this thing is going to use a store generated value. Okay, all right. We're telling it remember a default constraint on that column that if we don't include the value when we update, we'll then run this function and get a new sequential ID for the column. If I spelled that right and everything, we'll see if this works.
Yeah, looks good to me.
Didn't crash. Okay, good. So we'll get some interesting things showing up here. First thing is key value before add is the default. The key value after add also appears to be the default. And this actually goes back to something that Shai mentioned earlier, which is users should typically, you didn't say it this way, but the way I'm interpreting it is you typically shouldn't really care about temporary values. They're an internal aspect of EF. And in fact, we used to just set temporary values onto the instance of the entity itself, just so you had that's the value we're using. And we stopped doing that, I think, in 3, maybe 5, I'm not sure. The reason being because that it so easily then becomes a permanent value. Like if you detach that entity because something went wrong and then you reattach it, and we've had several bugs filed like this, we now try and insert an entity with a big negative number because we don't recognize that that's a temporary value. So what we do now is we track that value and we give you access to it, but we don't set it on the entity. And so this is a case where if you asked EF what the current value for the property is, it will give you a different answer to what the value on the property actually is. And it's going to give you the value that we're tracking for it, in this case, the temporary value. So let's run that again, printing that out, and we should see something very interesting. Okay, so now you can see, yes, EF has generated a GUID, just like it did before, except not just like it did before, right? Because actually the key that we want is the one that the database generates. So this is a temporary GUID that it's generated. So EF has some key for it until we start tracking. we didn't send it to the database. Remember, Shai said, look, we sent it to the database. We didn't, right? Instead, we outputted it. And now we get back a new GUID, and it's a different GUID, right? So the actual permanent key is different from the temporary key we want. So this is a case where the client generated a temporary value. We use that until we sent to the database. When we sent it to the database, we got back the real value, and then we would update that key value everywhere it needs to be updated. So people sometimes don't even think about this, but EF also updates foreign key values with the new value after you save, so your graph is consistent. Okay, you want to say something, Shai?
Is it worth asking? So why shouldn't I use server-side generation all the time? Like, why not just do a new sequential ID?
You're really putting me in the spot there, aren't you? So
I mean, I can answer that myself, but I mean, it's fun, more fun this way.
Historically, and I'm talking 15 years ago when I started on EF, it was very common for people to want to have the actual generated key value immediately. And this is one of the reasons that people actually started using GUID, I think, more commonly, is because you could actually generate a real permanent key value that you could use in your tracking and reports and in your UI and everything right from the beginning. And so people have always asked to be able to do that. And in fact, it's one of the, like I said, one of the advantages of doing GUIDs. But GUIDs have other uses as well. And so you may want GUID in your database, but not because you care about generating those key values. And that's where Shai and I have been discussing the default, because maybe that's the more common case now. And so maybe we should just be doing generated GUIDs by default, database generated by default, so we get all the proper sequential stuff. But it would be a pretty big breaking change to do that right now. So I don't think we will, but it's an interesting, things have moved, and it's not clear how much the permanently generated values is super important to people anymore.
There's the other aspect, which I was answering some messages, so I'm not sure if you addressed this, but there's the aspect of what happens if, so okay, beyond this, if you happen to be inserting both a blog and its posts, and the blog has a GUID key, then think about this for a second. If you're generating the key, the GUID on the client side, then you can insert the blog and also all of its posts in a single database round trip, right?
Yeah.
Because you know the key up front, like very early, so you can pack all of those into a single update, and all the foreign keys of the posts, you know, to stick the generated GUID there, because you just generated it client side. However, if you're using the second technique with a server-generated GUID with this new sequential ID function, you can't do that, right? You have to first go to the database and insert the blog. You have to wait and get back the response so that you actually get that value from the database. And only at this point can you insert all of the posts. So database-generated IDs have a performance issue, so to speak. They require another round trip for the case when you're inserting a principal and dependence, right? So if it's client generated, you can do that in a single batch, in a single round trip. Whereas if it's not client generated, if it's server generated, then you can't. You have to do 2 round trips. So that's something to kind of keep in mind. That's actually, I think, a very important difference between client generation and server generation. There's pros and cons to each approach. I think we know by now that doing the new sequential ID would probably result in better performance overall, because SQL Server is generating them in a single place and can, the GUIDs will be higher quality in terms of indexing. However, if what you're trying to do is to minimize round trips to the database when inserting dependents, then that actually flips around, and it's better to be doing that on the client. So
hopefully I've done a demo of that. So let me run it, and we can actually see the 2 round trips versus the 1. So this is database generated. So this should still incompatible with int. Oh yeah, okay. They do need to be GUID keys. I just copied and pasted code where they're ints again because it was from later on, not GUID generator. Okay. So what I've done is I've added a relationship here. So I'm adding a user, and I've also inserted an account at the same time. And we've got database generated. So Shai.
Sorry, I'm looking at some answers in the chat. I'm with you.
As default. Oh, I didn't make the other one. We also need the count one to be set as database generated. Otherwise, we don't need to do 2 round trips because we're not generating a value for it. Okay, here we go. So two round trips. So this is database generated. The first round trip we had to generate to get the ID of the user, right? So we inserted the user and we got the ID back. And we needed that because we needed to set it as the user ID foreign key, right? We needed to set it as the foreign key when we're inserting the account. Okay. Well, if we go back to our code up here where we are setting these things as generating the database. So now both of these key values are client generated. Now we should see a single round trip to the database because all the values are known up front. And indeed we see that, right? So we see we're inserting users and also into account in a single round trip, and all the IDs are known up front. So the user ID can be put into this user at the same in the same round trip as we put it into its foreign key slot.
I think it's really, really cool how EF has all this smarts built in, and you don't have to worry about this stuff. So yeah, you have to understand it enough to choose your strategy, client side or server side, right? But once you do that, like EF tries to do the best it can. It will batch. It will do a single save changes batch if it can. If it can't, it knows how to do the two batches and take the answer from the first one and stick it into the second one. Always just imagine the work you'd have to do yourself if you had to do this, right? Like if you had to program this without EF, you'd have a lot of work on your hands from executing one thing, getting the generated thing back, sticking it in the other one, sending the other one, getting it back. Like that's a lot of work, and EF is kind of doing that for you, and hopefully in the most efficient way possible. That's basically what EF is about.
Okay, so what I've done is I've changed these to integers so we can see what happens with integer key generation. So we've been doing GUID key generation, but I'm going to run this now, and this is on SQL Server. Again, I did something wrong.
Your relationship is somehow
can't determine the relationship. Oh yeah, because foreign keys need to match primary keys.
You can't have GUID here and in there, right?
Exactly. That probably should be nullable as well, but it didn't matter. Okay, so what we've got here is we're printing out these key values again, right? So the key value before add is the CLR default, as we'd expect. After add, it's actually very similar to the GUID one, right, where it was store generated. In this case, you can clearly see that that's a temporary value. So then when we do the insert, it's 2 round trips again, right? Because we don't know what the value is, so we have to do the round trip for the user first. And in this case, we don't send anything, we just get the ID back. And of course, it generates 1. And so afterwards, we see the key value of 1. So that's integers. It's actually straightforward, and that's what you're using all the time. Basically, if you just do public int ID get set, this is the mechanism that EF's using. It's generating a temporary value, and then when you save it, it'll have the database generate the correct value, and it will return it to the user. But there's other ways we could generate integers, right? We don't have to just use. Actually, good point. I didn't show that. By default, we created an identity column here, right? Remember how we were talking about on Postgres, if you create a generated column, you can create one where you can insert values explicitly. On SQL Server, that's not going to work. So with an identity column here, if I give this an explicit value and then try and run it, SQL Server will throw. We have an issue on the backlog to automatically switch the flag like Shai said. But basically it said, you can't insert that because identity insert is off on that row. But EF can use different strategies for key generation. An obvious other one is to use a sequence instead of an identity column. So if we use the sequence, let's just do it and then we'll look at the SQL that's generated. So in my configuration here for user, I'm going to do d property. Right, so we've got these things. We can do use identity column. That's the default. or use sequence, or use high-low. So I'm going to do use sequence, and we'll come back to high-low in a second. So I'll actually do this for both of these just to be consistent. It shouldn't matter. So let's look at the database schema that's created now first. So what we've got here is a database schema where we've created a default constraint on the ID column. So remember, this was just identity before, but now it's saying, actually, what you're going to do is get the next value from this sequence. And we also created the sequence for it. So we've created a sequence for this table, and we're going to get keys for this table from that sequence. Likewise, we created a sequence for the account table, and we'll get keys for the account table from the account sequence. So functionally, this is very similar to identity, right? But it's a different mechanism in the database. If we run it just, oh, I just did run it. If we run it again, so I can see the actual output, you can see before add, it was 0. After add, we got a temporary value. After save changes, we got the value back. So from our side, we saw no really different behavior. And in fact, even what EF has to generate is the same, because it doesn't actually care whether the value comes from identity or from a default constraint with a sequence in it. But it is a different mechanism under the hood, and I'm going to now set the key value explicitly here. I'm not saying this is a reason you should use this. Actually, I'm not even sure this will work because I didn't test this, but let's hope for the best. Let's say I set this to 77. Remember, now I've set that value, EF will try to insert it explicitly. It did work, good. And because it's not an identity column anymore, see, now we said, okay, the key value before add is 77. This actually means the value generator never kicks in, remember? So after add, it's still 77. The tracked value 77 is just 77. And then we send it to the database. And we said insert value for ID. And in here, it should be somewhere 77. And that failed, right, with identity. But because we're using sequences, it works because it's a different mechanism under the hood. I don't know if you want to say anything about that, or I'll go on to high-low.
I'm deep in the chat. Sorry, I haven't been about.
That's good.
Lie on ahead.
Yeah. So there's another one that you might have saw when we were doing this before, and that's use high-low. So what is high-low? Well, there's a lot of definitions of high-low floating around. So what I'm going to say probably doesn't align with what you're thinking of, but the general idea is to ask the database for some set of values that we can then use on the client to generate values without having to ask the database for it, but to have the actual permanent values immediately that we start tracking the entity and not later. There's various reasons for doing this, but going back to our round trips thing, I think that's possibly one of the most convincing reasons, is that then when I do a insert, a dependent and a principal, a foreign key and a primary key that needs to come from, I have all the values at the time I do that. I can do one round trip. The downside is you need to do some kind of round trip to the database to get that set of key values that you can use, but EF doesn't run that every time. It runs it once, gets a set of key values, uses that for however until they run out basically, and then gets another value. So you're kind of atomizing that additional round trip over a whole bunch of different operations. So let's run that and just see what it looks like in terms of the generated values. Okay, so you can see that all we did, we created a table, and in fact, it's just a simple key column. There's actually there's nothing in here that says this is generated or has a default value or is identity or anything. It's just a straightforward vanilla column at this point. We also created a sequence. In this case, we created an entity framework high-low sequence. We actually create one that's shared across for this various performance reasons. You can create multiple if you want, but in the high-low one, you've got to trade off the contention in the database with the having multiple sets of values that then end up with large gaps in and stuff. So that's a tuning thing. But fundamentally, what matters is that we've created a sequence, and we actually increment it by 10, right? So this is because this sequence we're going to be used to get sets of 10 key values. So that's the structure of the database. Now, did I comment out the code that was inserting stuff? Key
No, it's
value after. Oh, it's there.
yeah,
No, but
right at
it's
the
not.
top.
It
No?
is. I'm not
The
seeing
inserts?
key value before. Say, let me just run it again.
Oh, that. Okay, yeah. Right.
Oh, here we go. Yeah. I think, when I'm in presentation, I should file this bug on Rider, because in presentation mode, the log output gets messed up more than it should, I think.
Okay.
Anyway, so the key value before add is 0 because it's the default. EF hasn't seen it yet, so it can't have done anything to it. Okay, but now add is called. We get a database round trip on add. This is that case where add async is useful. In fact, I'm actually doing the wrong thing here, because this is a synchronous database round trip. And that's because on this call to add, it needed to go and get that list of key values to use. But once it's got them, now it's got the key value, and then when it does the inserting into the database, it can do a single round trip, because even though these are permanent database generated keys, we have the value to put in user ID at the same time as we're putting it in its principal column for ID, and so the high-low generator can give you that advantage. There's all, like I alluded to, there's issues around spaces and contention on sequences in the database if a lot of things are, various other things. So it's not necessarily a panacea, and I wouldn't just immediately go switch everything to high-low. But if this is something where you're really trying to optimize round trips and you're using integer keys, then it has a real advantage for doing that. Okay, I think we probably should end there. I've got a few things where I said if we have time, we'll talk about it.
Yeah,
But
we're way.
we're
Maybe
way
though,
over.
if you're okay with it, I'll do a very quick summary of ints versus GUIDs and the various options.
Yeah, absolutely. That'd be good.
So it's like GUID keys versus int keys, right? And generation. So how does it work? So it's a mirror image. It's quite interesting. GUIDs get generated by default on the client. So EF does that for you. But you have the option to switch to explicitly opt into server generation by just defining has default value SQL and doing new sequential ID or whatever, right? So the default in most relational providers is just going to be do it on the client by default, because why not? But if you want to switch to server, you can by defining a function. On ints, it's exactly the opposite. By default, on ints, the default is going to be generate on the server via identity columns on SQL Server. Also on Postgres, they're called identity columns. Doesn't matter. Auto increment. But you can switch to sort of client generation. It's only sort of by using high-low. I'm saying sort of because obviously you can't do full client generation of ints, because they would conflict, right? That they can't be unique if you're just generating them on the client, unlike GUIDs, which you can. So
We
what
never
high-low does,
say that, but that's actually a very important point to
that's an
understand, right?
important point. Yeah, maybe we should always start it at the basics, right? Like that is the fundamental problem. That is why we by default always get do server-side like database generation, because that's the way to enforce uniqueness of your keys, which is the whole point of having keys in the first place, right? But if you do want to optimize for round trips and various other things like this, you can opt into mostly client-side generation, which basically reserves a range of those IDs, fetches that range back. Like EF takes care of all this, but fetches, let's say, 100 IDs, and then it's going to basically work in client-generated mode until that supply of 100 keys is exhausted. That's basically what high-low is all about. So it's a mirror image. GUIDs, client generated by default, but you can switch to server. Ints, server generated by default, but can opt into mostly on the client. That's basically the image here of how EF does things.
Exactly. And for completeness, other types are not value generated by default. We actually changed that because strings used to be value generated by default, but we changed that. But you can actually say value generated and add, and then we'll select a value generator, and I think we basically put GUIDs into your strings for you. So there are types where we don't have, and decimal I think is another one similar to this. Like we don't do it, but if you have a key that's a decimal, then it will get a value generator selector for it. So there are things there where you can by putting on add on a key property, it will actually get values generated, even though that wouldn't be the normal case. Actually, a lot of people use that without realizing it, because the ASP.NET Core identity model uses strings by default, but relies on this behavior in EF Core, where it will generate a value, a GUID, to put in the string column.
That just makes me shiver in my seat. But
yes, it was designed a long time ago with a lot of constraints.
Yep.
Like databases not supporting GUIDs.
If you want, nowadays in any modern database, if you want to store GUIDs, then you have GUID types in your database, which are way more efficient than storing GUIDs as strings. They're not stored as strings. They're stored as in an efficient byte representation. That's much better.
Yes. Okay. There's one thing I'm going to mention right at the end here, because I would feel bad for not mentioning it after talking about value generation and keys. I don't know if I'm going to demo. We'll see how it goes. So if
We
you
are
have,
an hour and a half over, yeah?
I know. That's why I'm going to just try and say it really quickly. If you have a key that is marked as value generated, so a GUID or an integer, for example, by default, by convention, are marked as generated, then EF will actually use that information to determine whether or not an entity should be added or inserted in certain circumstances. So for example, if you call it, not added or inserted or updated. So if you call the update method, for example, and we see an entity and it has a value generated key, and that key is the default, then we know that that entity cannot exist in the database because it doesn't have a key, right? If it had been inserted into the database, then by some mechanism, it would have had a key generated. So we can say, okay, that must be new, and we put it in the added state. We can't do that if you're generating your own keys, because we don't know what keys are valid or not. Now we could, for example, say, let's assume the GUID empty GUID is never set, and so that's always needs to be set and everything. We did that in EF1 and it was a complete disaster. There's so many cases where it doesn't quite work like that, and it doesn't. So basically what we say, if it's not value generated, then all bets are off in us being able to determine the state of the entity based on the key value. It could be anything, and it could be added, or it could be, it could be new and need inserted. So it could be the added state, or it could be existing and need updated, and we can't tell that. And the reason I'm saying this, where this bites people the most is GUIDs, because people will not necessarily recognize that GUIDs are generated by default, and so they will treat them as not generated by default, and then they'll end up with states, with entities being put into a updated state, like ready to be existing, because it's got a generated value, and so we assume that value is correct even when it isn't. So the end take home from this little thing that I'm saying here is, if you've got GUIDs, if you're using GUID keys and you're not doing value generation, you're always explicitly creating your key values outside the application, which is normal, a common pattern. Switch off, tell it, configure EF to tell us you're doing explicit key generation. Otherwise, EF will assume that you're letting EF generate the keys and its logic will not behave in an appropriate manner. Okay, that's my final warning.
Hopefully you all got that.
Yeah. It's too late to do a demo on it, but yeah, anyway,
I think
I'll put an example of it in the code when I upload it to GitHub, okay? And I'll put some comments on it. So if you want to follow up on this more, look on that and then reach out to us if you have questions or whatever. Okay, I think we're done, right?
I think we're done too.
But we have something cool scheduled 2 weeks time, right, Shai?
In 2 weeks time, Michael Steib of GraphQL.net fame will be here again. So we've hosted him before, but he has some cool stuff. So anybody interested in GraphQL, or even if you're not, but just curious about it, please join us in 2 weeks, because he's a great speaker. He does, very nice demos. I'm always, wowed away when he shows something. It's super cool.
This is the hot chocolate, strawberry pop cake, all that kind of chili cream stuff. And if you're not interested in GraphQL, you should be. It's super interesting and important.
Exactly.
Okay. Well, thanks everyone for staying around for an hour and a half again, and hopefully this was somewhat interesting and useful.
In our 1 hour long EF community.
Exactly. So yeah, we'll see you guys next time. Thanks. Bye.